Hi everybody. Hey, wanted to put this together for the 89 on how to do some of the things. Uh, so the first thing we got to make sure we do is to go to the mode. Okay. So if I go to the mode, you want to make sure that I'll zoom in a little bit. By the way, anytime we save anything here, you have to make sure you press enter. Okay. We want to keep it in function. Okay. You always want to be in radian mode. Okay. You do not ever want to be in degrees in this class. So please make sure that you do put it into radian mode. I think the default is degrees. Okay, some of the other things you want to make sure is you want the pretty print to be on. It should be on. I think that's the default. So it puts it into it puts the scripting when you do something into exactly what you want it to look like. Okay, I leave the split screen at full. Okay, exact and approximate and auto. Okay, I usually keep it on auto. Auto means it will put it in the best form. If it can put it into a decimal, it will. Or excuse me, if it can put it into a fraction, it will, because it will leave square roots in here. If not, it'll automatically put it into a decimal. If you always want decimal, you can put it in approximate then. But I'm going to show you if you leave it in auto, how to get the decimal approximation each time also. So I have a tendency to put it on auto. You may prefer approximate, doesn't matter. Okay? All right, so I think that's it. Yeah, so I'm going to make sure that I go over here and press enter because now it is saved. All right, so a couple things we're going to make sure you know how to do is solving with the solve button and solving the graphing. Solving with the solve button is great, except when it's a periodic function like the sine. Okay, so because it's great, but it's not. So I would, in many cases, if it is a period, and because of solving is kind of becomes many people's default, there are times when you really need to do the graph version. Okay, so I'm going to do the graph version first, and I'm going to solve to find, by the way, it could be that these two are equal to each other. Okay, and you could do y1, y2. What I think is easier is to do it as we want to find where those are equal to each other, is to go ahead and do write it as a single function and find where it equals 0. Okay, so you can do it either way, graph where they find intersect, but I'm going to go ahead and go to y equals. And if you look, it's already typed in. So I'm going to go ahead and clear that out. So the sine is here. So I'm going to do the sine of 2x, okay, minus a half. And it will leave that as a fraction. All right. So if you notice, that little dot in between implies or tells us that it's truly a multiplication. Okay. And I'm going to go in a slight diversion now and go back to my home screen and explain why that's important. Okay. If you are looking to do F18, by the way, clears your screen. Okay. So if you type in XY on an 89, that is a single variable if you just type it in that way. So now you have more than just the 26 letters as your variables like the 84 has. It has many of them. You can do XYZ as a single variable. But if you want it as separate variables, you must do X times Y. And then you notice that there's a multiplication in between. That is very important because if you just type in XY and you're plugging in values for both, I got news for you. It won't know to do that unless you originally put an X times Y in between them, because that is an important thing. On an 89, a variable is a variable is a variable all the time. Okay, 84, that's not the case. Just so you're aware of it. Okay, this is a computer algebra system, which part of that is that variables do not have numbers in them until you plug them in. Okay, there's an important distinction in there. Okay, so if I go back to y equals, and I'm going to hit zoom 6, so we have the same one, or zoom. I'm sorry, F2 is zoom. Okay, now we have our standard window, and if we look at that, we have a ton of solutions. Okay, so I'm going to adjust my window, just so I'm going between, say, y's between, say, -2 and 2 in graph. Let's go back in the graph. So now we've got a little bit smaller window. Okay, I do want to point out, remember, why would we want to do this? Because you think about how many times we're saying the derivative equals 0, and there are many of them. So I can only do one at a time this way, and I'm going to go up and do F5, which is math. In this case, I'm going to find the 0. You notice intersect is there also. Okay? So if you did them as y1 and y2, you'd have to do intersection. Okay, so I'm going to find where they equal 0, and you have to do lower bound. On an 84, it said left and right. Here it goes lower, which means left, and upper, which means right. So I'm going to hit enter, and now I'm just going to cursor till I'm above it, and it finds that first one is 0.261. Okay, I'm going to go do the second one. Maybe I need to find more than one. And then I'm going to do the same thing. By the way, at least 3 decimals. So actually, that would be 0.262. So I'm going to do F5, 0. Now I'm going to go find that second one, and I am to the left of it. Hit enter. Go to the right of it, hit enter, and there it is. Okay, and by the way, that is essentially 0. Okay, but that one is at 1.3089969. Okay, what happens if I do the beautiful solve? Okay, so if I do solve, or home, and I go ahead and do F2 solve, and I'm going to type in sine, and by the way, remember I am in radian mode, minus 0.5. Okay, with solve, actually I'm going to do minus a half. With solve, you always have to have it equal to a number. By the way, you could have done it this way, or you could have set them equal to each other. Didn't matter where you put the equal sign, but it has to be equal to something. Now we need to tell it what to solve for, so I have to do comma x. If you don't do comma x, I'll show you what happens. You get this error. Doesn't know what it's solving for. Okay, so you hit escape, and then you just do comma, which is right here, x. Okay. And I hit enter, and if you look, it gives me this gobbledygook. And you're like, what in the world is that? Well, if you go back to your graph, if you remember, there were a whole bunch of them. It's giving us all of them. But it's messy. Okay, so if I go back home, this means a constant. So that means 12 times some number n plus 5 times pi over 12 will give, that's a formula for the general solution, or there's another set of them, because remember this is periodic, so this will actually give it, and then it would be 12 times n plus 1, 12n plus 1 pi over 12. Well, why is that important? How does that help me? Okay, let's go list them all. Well, when n is 0, I just get 5 pi over 12. Well, this is just saying I'm adding 12 each time, so that's 17 pi over 12. At 12 again, I get, what, 29 pi over 12. Okay, if I go do this one, I'm only doing the positive, so when n is 0, I get pi over 12. So that was actually the first one these were our first two we came up with. And then 13 pi over 12 goes on forever, because it will, actually it's a formula for all of them, but you have to recognize that that's a constant and what that means. Okay? So there are, I just cursored over to see both of them. Okay, that's good and that's bad. I really like doing the graphing on these whenever it's a periodic. Okay, so if I did you could also, never mind on that one. So if I want to do this one, another solve, I want to find the intersection of those two. So, and by the way, some of these will take a while. So if I do F2 solve, I have to do it as x times, and that's an important distinction. E to the x is right here, and then x, so our E button is here, is equal to 8 minus x squared. Okay, so I've set them equal, or I could have done this one minus that one. It does not make any difference. Okay, let me make sure you can see that from the glare. This time it's not off my head. Okay, comma x. All right, and I think we're going to get a warning here. Yep, it says more solutions may exist. Okay, so we've got a parabola, which you know goes like this. It's thinking, takes a while. Some of these are not automatic. Okay, so it actually gave me two solutions. So my first one would be at negative 2.85729, and I cursor over, and I get the other one is 1.428. So that's in decimal form. Those will only be decimals. Okay, I just want to point out you could have also entered it as minus and done parentheses equals 0 and gotten it that way. Take a minute, but it will find it for you. So solving finding intersections where derivatives are 0, it's a wonderful tool for it. So I at least want to show you how to do that one. The other thing is how to take a derivative on here. Okay. So, by the way, this is something you need to play with a little bit because you'll get an appreciation for what these exact and approximate are. And actually, I'm going to give you an example. So if I do square root of 5, when I'm in exact or auto, it's going to give me that value. It's going to give it to me as a square root. Okay. If I want to get the decimal version, I have to do green diamond, and the approximation is down there, and that will give it to me. If you put it on approximate all the time, it will give you the decimal every time. Okay. You know, if your answer is say pi divided by 6, the nice thing is it's going to give it to you as pi over 6 if it's in auto or exact, okay, because it can get a value for you. So if I do green diamond enter, I then get the decimal version. Okay, so if you want to go or approximate all the time, it'll give you the decimal all the time. Okay, last thing I need to show you is how to do derivatives. All right. There are two ways to access this D button, which is our differentiation. Okay, so you can go up to F3, and it's your first choice, or it's down here above the 8, and you can do second 8 and do it. It doesn't matter which way you do it. I get the same thing. So we have to say derivative of 3x to the 4th minus the sine of, and I just randomly made this one up, 2x. And then we got to say what variable are we differentiating with respect to. I have to do comma x. Okay, so that found the first derivative for me. Okay, kind of cool, huh? Well, why do I have to do this? Well, I have to be able to know this because you have to be able to do it by hand also. Because part of the AP exam is with a calculator, part of it is without. Whoops, sorry, you couldn't see that. So I just did the function, comma x. Now, if I want to do the second derivative, I don't need to go take this and differentiate it again. I can just do comma 2, and that's the second derivative. Kind of switch the order of the terms. And if I do it again, I make it a 3, I can make it the third derivative, and this would be the fourth derivative. So if you look at this, this is the pretty print. It's saying take the fourth derivative with respect to x. When we were up here, this is where the pretty print came in. The derivative, the first derivative with respect to x was this one. Okay? All right, the last thing I want to be able to show you is what if I want to find the derivative at a point? I'm going to clear a bunch of these off. Okay, so you have two options. So we can go get that derivative. Okay, and I can go up and grab, ooh, I don't want that one. Hold on, let me go back to the first derivative. Okay, all right, so here's our first derivative. And I got two ways I can do this. I can go up and grab this, and then insert a value by doing the with bar, which is right here. This is beautiful. With x equals, well, I'm going to do pi over 6. Oops, not x. Pi right there divided by 6. If I hit enter, you notice it gave me the exact value. If I want the decimal, I do green diamond enter. Okay, so that's one way to do it. Okay, the other way to do it is you could go up here and start with that derivative button, derivative thing, and then after it, do with x equals pi over 6. Okay? You notice it gave me the same thing. So you can do it in one statement or you can go take the derivative, go grab it, and then plug it in. Okay, great way for number lines because you can get values. If you want to go test a number, there it is. You know, if you've got a derivative and you want to find the value at this point, and is it positive or negative? Hey, it's positive, right? Okay, let's say I went and did that same one at pi over 2. Okay, it's still positive, right? So I didn't get a sign change, but if let's say I did it at negative pi over 2, now I actually had a sign change somewhere in between there, right? So can help you that way, all right? So what I'm expecting you now to do is the derivative at a point, or find the derivative, the value of the derivative at a point, and also solving, okay? But you need to play around with that exact approximate as to what works best for you. There are a bunch of other things on here that make sure that if you do more than one variable, that you have to put the multiplication in between there. If you don't, okay, because by the way, yeah, okay. I'm going to stop it there. I don't need to make this more complicated. So thank you, everybody. Have a great day.